early. Good morning, everyone. So today we have a lot going on. If you're in the Morristown area, it's the St. Patty's Day Parade downtown. So unless you want to sit in traffic, make it a very intentional move to be downtown. So happy St. Patty's Day. All right. So a couple of quick announcements and then we'll get started. We sent out an email for those of you on our distribution list. And if you're not already on, become a member so you'll get our emails. There is an open treasurer's position. So if anyone is interested in joining the board of Morris Museum Astronomical Society, please let Jeff or I know, and we can talk to you about more details. Some astronomical events that I'll share, and then we'll talk about outreach. The new moon is March 19th. So for those of you that want to go observing, we'll have a nice dark sky. Artemis 2 mission has been delayed until April 1st at the earliest. So for those of you interested in that, please follow NASA on their website. Often we'll post updates about the missions and what they've achieved and what they're looking to accomplish. April 22nd and 23rd is the Lyrids meteor shower. So it's an average shower, usually producing about 20 meteors per hour, but still worthwhile if we have a clear night for you guys to take a look. I'm going to pass this off to Jeff for some outreach events, then we'll talk about programming and introduce our speaker.
Thank you. Okay, good morning, everybody. Couple of things about observational astronomy coming up. First of all, we're in the middle of galaxy season. So this is the time to look at galaxies, and sort of March, April into even May, there are a lot of galaxies that are visible, and it's a good time to view them or to take pictures if you're into that sort of thing. It's also the month of March is the best time to do a Messier marathon. If you guys know about the Messier catalog, Charles Messier was a comet hunter, French comet hunter in the 1700s. And he kept bumping into these things that looked like comets and getting all excited and then realizing they weren't a comet. So he made a catalog of them. So he'd know in the future, this is not a comet, don't worry about it. And he has a catalog of about 100 objects, or 110, I think they're up to, which some other people contributed to over time. But there's a period of time in the year, and it's right now in March, where you can, if you're really good and really fast, you have about 6 minutes per object, you can find every one of the Messier objects in one night, provided you're willing to stay up all night. But this is the time for that. So those two things, and then in April, middle of April is International Dark Sky Week. So there might be some activities going on around that in the area. We don't have anything planned particularly for International Dark Sky Week, but there might be some other organizations that are doing things. So what are our plans? Well, we have on March 28th, we have an outreach scheduled for Mountain Lakes Recreation Department. It's going to be at Halsey Frederick Park, which is off of Powerville Road. It's across from the Mountain Lakes High School. You're all welcome to come with or without telescope. You don't have to bring a telescope, just come. Look through our telescopes. If you're going to come, please register on the website, RSVP, because that's the only way you'll get a cancellation notice. We don't send them out to the whole club, only to people who said they were coming. So that's March 28th. April 24th, we're going to be in Wayne, New Jersey at the Pioneer Academy. We've been there once before. I know Graham was there with us. We did a thing for the whole school at night, observing session. They have like a special event day at the school, and we're there in the evening starting at 8:30 to do some observing with them. And then the next one after that is May 4th, when we'll be at Glen Ridge Library, actually on Hurl Field, which is a baseball field near the library in Glen Ridge, New Jersey, and that's another outreach observing. So again, you're welcome to come to any of these. You don't have to bring a telescope. You don't have to show other people of the public things through your telescope if you don't want to, but please come. It's a fun event, and the more the merrier. So thanks.
All right, thank you. So we have We have a lot of those wonderful outreach events. And then finally, I think many of you know that our programming stops for the summer. So we have, after today, 2 more programs with speakers scheduled. So Al Witzkel on April 11th, Saturday, here at Morris Museum, we'll be talking about the spectroscope, Swiss Army knife of science. It's a history and a demo on how astronomers figure out the chemical elements in stars without leaving Earth and derive so much other interesting stellar data. So that should be a wonderful event on April 11th. And then finally, to close off our spring series of programming speakers, on May 9th at Morris County Library. So just please note, May 9th will be at Morris County Library. For those, some of you have already been there. Charlie Bracken is releasing his new book, and he will be presenting some of the topics there and have books available. Different types of deep sky objects and the astrophysics behind them, with lots of images that he'll get to walk us through. So those are our upcoming programming events. And last but certainly not least, today we have with us Lonnie Bunis, who's been here in the past and has really presented some engaging content. And I think he has some fans who've returned, so he has quite a following. Today we're going to talk about what wondrous worlds we witnessed, a century of planets. And I'd like to welcome Lonnie.
Thank you, Minnie. Oh, thank you very much. Thank Nina and Jeff and all of the MMAS for making the series possible. I'm going to depart from my usual kind of talk. This is more personal, personal history of myself and my father having lived through the last century of amazing, incredible developments in planetary astronomy, the study of planets, of worlds. The very first one I saw through a little telescope this long was the moon. And it struck me that I was looking at a world as if I were flying above it. And so that's what inspired this talk. And I'm going to begin with the plan. Let me just clean this up. So first, I'm going to use the planet Jupiter as an example of the incredible changes in technology used by professional astronomers and amateur astronomers. I am not a professional, I'm an amateur astronomer, so I do this for love, not money. Then we'll look at terrestrial planets. Famous example, anyone? Earth. And then we look at dwarf planets like Pluto, which some people feel was demoted. We look at giant planets, which now have a new name, and the 5 most exciting moons, because today we don't have time to talk about all 419 of them. And finally, I end with exoplanets. What are those? Beyond, right, the ones beyond the solar system. I thought it was an amazing coincidence that my choice, the 5 most exciting planets, was number 5 on my list. Pure coincidence. I start with my grandmother, who was born in 1897. Shortly after that, there was the first photograph ever taken of the planet Jupiter, and it was done with film. Younger members of the audience here won't know what film is, right? It was an actual physical medium on which people recorded pictures. Not from a cell phone, not from CCD, charge coupled devices, but from a chemical process called film photography. And this is the very first shot of Jupiter with the great red spot. Doesn't look red here because it's black and white. And one of the belts, the equatorial belts of Jupiter. Not very good. It turns out film photography, even today, even in 2020, film photography is not easy to do of the planets. They are far away, they're small, and the Earth's atmosphere interferes. If you look at the bottom, the planet Mars, captured by this amateur astronomer, let me move that out of the way, he claims that you can see the polar cap at the top of Mars. I can barely tell that there's something else there. That is ice, frozen water, and carbon dioxide. From 2015, a high school student used a 6-inch telescope to capture Jupiter and clean up the image with modern software and processing. This is not with film. That's about the best you can see Jupiter in a small telescope. I see a couple equatorial bands, each as wide as our entire world. Jupiter is about 11 Earths wide. It's a big planet. My father was born in 1920, and he was growing up as a kid in the 20s and 30s. He had a big band. He was a professional violinist, very skilled at his craft. He started learning at the age of 5, and he memorized thousands of ethnic tunes in his head. He could play them from memory. In his time, film was developed faster and faster, better and better. By 1946, you know, to some of the young members of the audience, sounds like a long time ago, but it really wasn't. In 1946, Kodak developed this high-speed film that both amateurs and professionals could use and develop themselves. This was a big breakthrough. It was used to get fast captures of images of planets like Jupiter here in one of the world's best telescopes at the Lunar and Planetary Lab in 1969. That was considered some of the best photography you could do of the planet Jupiter. We recognize this big red spot here, which goes by the scientific name, Great Red Spot. Brilliant. Now, compare that with what amateurs can do today. Incredible. Andrew McCarthy of Arizona, he took 600,000 short exposures rapidly. Now, Jupiter was rotating as it did this. Jupiter rotates just like the Earth. The Earth takes 24 hours. Jupiter only 9 hours and 55 minutes. So in the time that you're taking 600,000 pictures, the red spot's going to move as Jupiter rotates on its axis. So there's a couple things that modern equipment can do, modern software. The first use of such software with CCD, charged coupled devices. CCD takes the photons of light that hit it, convert it to electrons, and that current is recorded in special software and processed. So the first time that was used was in an 8-inch telescope to capture the moon, 1974. By 1985, it finally showed up as an ad in Astronomy magazine. Astronomy magazine is still in print, by the way. It's great for you beginners. You can read, if anybody still reads, I don't know. You can read it in print, you can read it online, you can subscribe, you can get it for free. I don't work for any of the sites or publications that I'm talking about today. I'm an amateur astronomer, unpaid. I'm doing this for fun. Charged coupled devices evolved over the years. Here's a giant array in the Sloan Digital Sky Survey Telescope. Big telescope, 98-inch mirror with a big field of view. Most astronomical telescopes are the kind that you see when you come to the MMAS and they show you the moon through the telescope. The moon is a ½ degree in angle. The whole sky is 360 degrees. The moon is a half of all of that. So it's a little bit of the sky, right? Most astronomical telescopes will see maybe half of that. 3.5 degree field is big. Another big one, 3.5 degrees, is the Vera Rubin Observatory with its giant telescope, the Large Synoptic Survey Telescope, and the world's biggest camera yet built. There's a picture of the focal plane right there, an astronomer holding it. There's the size of the moon. This thing is huge. It collects not 50 megapixels like my cell phone or yours. This collects 3,200 megapixels, 3.2 giga billion pixels. And it does that every 3 days. It will survey the whole sky over and over again every 3 days. Unprecedented. We will discover all new asteroids, new threats to Earth, near-Earth objects. And it does this with a mirror that's the equivalent of something bigger than the world's biggest telescope formerly, the 200-inch in California. There have been many bigger telescopes built since. Now, what do we amateur astronomers do with all this fantastic technology? What can we do with ordinary equipment? Well, at the Northeast Astronomy Forum, my wife and I attended this last year, and I just happened to catch a picture of myself in the lower left. This was taken by somebody else. I had no idea I was in this picture, waiting for my wife who was in the bathroom. This is a huge event, thousands of people, hundreds of vendors who sell equipment like this. Amateur astronomers can now buy cameras specially designed to photograph the sky quickly. This resolution is like a high definition TV. If you want to spend a little bit more than $179, there's one for $14,000. Some amateur astronomers spend a lot of money at their hobby, and they get better pictures. I mentioned that you have to do something special to get as clear an image of Jupiter as we saw before, something called stacking. Those 600,000 images taken by the amateur astronomer, pushed together, reduce the noise in the image, giving us a much clearer view. And there's also something else you can do called derotation, because I mentioned Jupiter spins so fast on its axis. The kind of software that does that, these are some of the most popular, the three most popular. Registack's good for PC users. AutoStacker is free. I like free. Don't know about you. And open source, Serial, sorry. Open source means that you programmers in the audience can contribute to the code. These things can not only stack the images to reduce the noise, but derotate the image. Let's say you're taking a picture of Mars and you want to get a clear view of Syrtis Major, the largest dark thing on that planet. Well, I built a 3D model and stuck a two-dimensional picture painted by an astronomer and space artist, William Hartmann. After sticking it onto a sphere, I was able to animate it this way. You can do this with 25 objects on my website, which I will shamelessly promote later. Now, what if you're looking at Mars and Mars is spinning every 24 and a fraction hours, just like us, a little bit slower, and it does this. Oops, now you've got a blurry image, right? It doesn't line up. Syrtis Major won't line up. The software, this modern software, can actually take that and figure out how to unrotate the image. Fantastic. Let's go back to slideshow. So over the years, we got increasingly more and more clear views of the planets as spacecraft went by them. When I was a kid, no spacecraft had ever gone to any planet. We didn't know what an asteroid looked like or a comet close up. No one had any pictures of any moon except one, the moon, ours. So we've seen incredible changes due to robot spacecraft. Voyager, 1979, more and more clear. Voyager's movie, have you ever seen this one, of Jupiter? As it was approaching Jupiter, Jupiter spun 60 times around. They captured it into an incredible movie. All of the stuff that you're seeing today is available free on websites. First color picture from the Hubble Space Telescope, HST, Jupiter. Not so great. We can do better. Amateur astronomers can do better, as you've seen, with ordinary equipment. And finally, the Juno space probe flew so close to Jupiter, we've seen incredible details. We're learning about the weather on Jupiter that will help us understand the weather on Earth. We've come a long way, baby, from 1879, the latest being the James Webb Space Telescope, which sees in infrared light the heat that our bodies are giving off. The James Webb Space Telescope could see that. Terrestrial planets, dwarf planets. Let's look at those. Venus, the second one from the sun, closer to the sun than us. For centuries, all people could see in the telescope was clouds. We speculated what might lie beneath those clouds. We had no idea. We knew that the clouds seemed to spin with a very slow period, longer than it takes for Venus to go around the sun. Very weird. And we speculated maybe it's teeming with life. Or maybe it's a dry, hot desert. No idea. These are all kinds of science fiction-y ideas. Clark Ashton Smith thought we'd find weird life in his science fiction tale from 1931. Well, the Russians sent space probes that landed on Venus, a whole series, and they got better and stronger because they found that the conditions were so harsh that the probes would get destroyed within minutes, then finally within hours. And after they used titanium steel and the strongest materials ever, the longest that a probe lasted was an hour and a half before it got pictures like this. 900 degrees, almost 900 degrees Fahrenheit on Venus, the pressure, 90 atmospheres like you get at the bottom of an ocean, and sulfuric carbon dioxide, sulfur dioxide, sulfuric acid. So the probes got eaten alive through acid, crushed, and burned. How'd you like to go to Venus? Anyone? Anyone? Not as bad as a New Jersey summer. One of the prettiest pictures of the atmosphere of Venus taken by the Akatsuki spacecraft, showing what that would look like. This was from in 2010. It turned out also that another space probe flew toward the sun, Parker Space Probe, and on its way to studying the sun, it got infrared pictures of the night side of Venus. Turns out that we think some people can see through the clouds of Venus. They're sensitive to infrared radiation, heat. And so the Parker Space Probe showed us that you can actually see on the night side of Venus, it's possible to faintly see some of the land features. Some people might be able to do this. There is an observatory in the mountains between Spain and France, the Pic du Midi, at which an amateur astronomer has gotten some of the best amateur pictures of Venus ever. With filters, we see features in the clouds. We can never see, with the daytime lighting up the clouds of Venus, never see the surface. Mars is a fascinating history of the planet Mars. It was this guy who caused all the trouble. He started it. Giovanni Schiaparelli, Italian astronomer, called these groove-like features grooves or channels. In Italian, that is canali. And canali confused an other astronomer, Percival Lowell. These are maps made by Schiaparelli, maps which I've used to create three-dimensional globes of Mars with different astronomers' pictures. Percival Lowell became very popular. He was a superstar at the start of the 20th century. Around 1906, there were lines out of the Hunterdon Hall in Boston, down the street, motor cars, horses, people waiting to see this guy. If you go to the Lowell Observatory in Arizona, to this day, it's still there. The great 24-inch refractor that Lowell stopped down to a tiny 3 inches to get clearer pictures. He ended up looking at the inside of his eye. And maybe that's why he saw canals. Carl Sagan, famous astronomer who had a TV series, Cosmos, had something funny to say about Lowell. One of the worst draftsmen who ever sat down at the telescope. Nobody else ever drew pictures the way Lowell did. Look at this. I took the map on top and straightened it out, corrected some distortions that Lowell added, made it more even latitudes, removed all the hundreds and hundreds of numbers of canals, and it still looks like, I won't say it in polite company, terrible. But I used this to create a 3D globe of Mars. When the first photographs of Mars came along, Lowell claimed, aha, proof, we've got pictures of my canals. Can you see them? No, neither can I. The first photographs of Mars are just about as poor as modern photographs of Mars. And yet, Lowell's disciple, Vesto Slipher, who became his assistant and then later director of the Lowell Observatory, extended Lowell's work, creating dozens of more canals, getting very few things right, even though NASA did use this map in 1962 to see where would be good places to land space robots. Eventually they did. In fact, there were 17 or 18 landings by space robots, space probes, 6 of which crashed, resulting in what we call the Mars curse. Modern pictures of Mars, this one is taken with film in the 60-inch wonderful telescope in Chile, 1969. You can see the quality. Still can't see the canals, can you? Very hard to see any details. And again, 10-inch telescope, amateur photography. This is much different nowadays. Damian Peach is an amateur astronomer who has a wonderful website, damianpeach.com, with wonderful equipment that he uses, a 14-inch telescope, an 11-inch telescope, a 6-inch refractor. Some of his telescopes use both a correcting lens and a mirror on the bottom. So the light comes through the lens, hits off the main mirror, goes off a second mirror up here and down again. That results in a very long focal length lens. And if you know optics, the longer the focal length, the greater you can do magnification. Spy satellites that orbit the Earth do this. They have long folded optical paths so they can see individual people from orbit. People, it's that good. Damian Peach has done some wonderful work on Mars. This is an unfavorable opposition of Mars. Mars comes close to us. It takes a period of over 2 years. We come close, but the orbits are not lined up perfectly circular. Mars is more elliptical, like an egg. And so every 15 to 17 years, Mars has a closer approach to Earth. This was not a good one in 2025, a really good one in 2016. Look at the amount of detail, including right here, a little circular feature by Sabaeus, the pipe stem, Syrtis Major I mentioned earlier, pipe stem, and a little circular feature. That is Schiaparelli crater, one of the biggest craters on Mars. Anybody see the movie The Martian? Yep, the action went to Schiaparelli crater. Check out the movie. These are incredible amounts of detail in modern amateur photography, astrophotography. It's amazing what we can do now compared to what we grew up with, what I grew up with. Percival Lowell also drew canals on Venus and Mercury. He was laughed at so hard by other astronomers that he had a breakdown of the nerves. Recuperated for a few years. When he came back, went back to the telescope, the canals on Mars were still there. Why? Because that's his Mercury, he was looking at the inside of his eye. By stopping down his big telescope to get clearer images, he turned his telescope into an ophthalmoscope. Right? The smaller the aperture, the smaller what comes out. It's called the exit pupil. It went down to about 0.5 millimeter. Your eye, younger people in the audience, have 7 millimeter pupils in your eye. I'm older, I have 5 in one eye, and I had a glaucoma in the other with surgery. So now this pupil is open to 8 millimeters permanently. So now, younger people in the audience, I can see just as well as you. How do you see canals? Well, you take a little light source, close your eyes in a dark room. A closet will do, right? Laundry room. Tell your mother, I'm closing the door. I'm not doing anything bad. I'm just looking at my eye. Stick the light source, hopefully an LED, to the side of your eye, not front, to the side, and wiggle it. Wiggle it. It fools your brain into stopping the filter, and you'll see something like my animation. You can actually see canals. I tried this with a cell phone, with the cell phone LED. It doesn't work. You can't get close enough. But try it out. If you can find a pen light. Do they still make pen lights? I don't know. Do they? Science fiction, space artists and authors were inspired by Percival Lowell. H.G. Wells wrote The War of the Worlds based on speculations about life on Mars. Lowell was convinced those canals were artificial, made by people or beings like us who wanted to take over our world. Edgar Rice Burroughs, inspired directly by the canals of Mars. 1912, The Princess of Mars was the first in a series lasting through the rest of Burroughs' life He died in 1950. Ray Bradbury, The Martian Chronicles. These are all very famous. And then my father remembered directly the 1938 radio broadcast of a recreation of War of the Worlds. It sent people into a panic when aliens from Mars landed in New Jersey. Oh my goodness. You can still go to the park. They have the monument right there where the Martians landed. They didn't. They didn't. People panicked though because the broadcast was so realistic, but a lot of people missed the opener, that disclaimer that this is fiction. Space art. Space artists like Ludek Peszek, who did the icy rings of Saturn in my opening picture, first slide. They devoted an issue of National Geographic to him in 1970. My father took me as a kid to New York City, to Manhattan. Not as scary then as it is now. We went to an obscure bookshop and found this issue of National Geographic, one of my most prized possessions, which has artwork by Ludek Peszek, Czech artist, who speculated that ice made from carbon dioxide and water could be found sublimating, going directly, evaporating directly from ice to vapor in Mars' thin atmosphere. He speculated about this in the 1960s and 70s. And astronomers, what do you think their reaction was? Yeah, he was right. They were wrong. Ice does form on Mars. And here's the proof. The Phoenix lander, 2008, its rocket exhaust blasted away the sand and found ice. Its scooping robot arm clawed away soil, and we watched ice sublimating, evaporating. There is plenty of water on Mars, huge amounts of water. It's just frozen right under the surface near the poles, deeper down near the equator. So astronomers, spacecraft people, astronauts, where are they going to go in the future? They should probably start setting up camp near the poles where the water is easier. But at the equator in the summer, it goes up to 68 degrees or so. So you choose. The planet Mercury, another terrestrial planet, has a weird rotation that we didn't find until the 1970s. We used to think one side of Mercury always faced the sun, as you saw in my animation. Well, astronomers didn't have the wherewithal to observe carefully from one superior conjunction to the next. Here are the two astronomers did the most studies 100 years ago of the planet Mercury. And their maps are crude because Mercury is small. It's a small planet. It's far away. We're looking through the Earth's atmosphere, which limits our resolution to 0.5, 1/2 second of arc. There are, in 1 degree, the moon is a 1/2 degree, remember? 1 degree, there's 60 minutes of arc. Each minute has 60 seconds. There's 3,600 seconds in a whole degree. 1,800 in the moon. Half of a second of arc is all we can do with telescopes because the Earth's atmosphere blurs everything. And so that's why these maps look so crude. But if Antoniadi and Rodot, the two people who studied Mercury carefully during the daytime, when it was easily visible, if only they had looked at Mercury when it was harder to see from one superior conjunction to the next. Let's do it again. All right, now watch. You see these 3 bright dots here? Watch when Mercury goes around the sun and comes back again. If they had only watched when Mercury was hard to see near the sun, they would have seen a big circular feature coming into view. They would have seen that Mercury does rotate differently from its year. What they did was they looked at the best time to see Mercury, the easiest, during the daytime in early May and early August. But if they'd only watched long enough, they would have seen new features coming into view. Mercury has a weird resonance in its rotation and its revolution around the sun with Earth, with us. And that's why for decades people thought Mercury had the same day as its year. That is a video narrated by my wife, who's in the audience, and who has not been paid for her work, unfortunately. I'll take you to dinner. So there are a lot of videos like that. There are some others that you can see on my website, Astronomy in Motion, that I'll advertise later. So the people 100 years ago did see real features. They saw that big basin, like a similar one on our moon, Mare Orientale. Whoops. Pluto, on the other hand, was seen as only a tiny dot. Even in the world's biggest telescope, the Mount Palomar 200-inch, that's 16 2/3 feet, giant mirror made in 1930 or so, they could tell that Mercury must be no bigger than 800 miles. I'm sorry, Pluto. They expected it to be much bigger for its influence on the planet Neptune. That's how they tried to find Pluto, by predicting its influence on Neptune's position. But in 1978, astronomers saw a little blob moving around the blob that was the best we could do to see Pluto. Here it is on the right, lower right. On the left, it's at the upper right. See it, the blob? That's a moon. A moon was discovered in 1978. This is a Hubble Space Telescope, first image ever taken of Charon. It's pronounced not Charon, but Charon in Greek, the large moon of Pluto. In fact, Pluto's more of a double planet. These two objects rotate around a common center, just as does the Earth and Moon. Did you know that? We're a double planet. The point that both planets, Earth and Moon, revolve around is inside the Earth, because the Earth is much more massive than the Moon. Not so for Pluto and Charon. They revolve around a point between them, and they are not this close together. Pluto has other smaller moons, and the best we can do with the robot probe New Horizons that went by in 2015, not very good. It was going by so fast, we didn't even get the entire surface of Pluto. Pluto was redefined from being a major planet, discovered in 1930 by Clyde Tombaugh, who I got to meet. I got to ask him a question. I asked him, do you think that Arthur C. Clarke's name for Pluto's wife is a good one in case we discover planet 10? How about Persephone, wife of Pluto, Hades? And Clyde Tombaugh said, yes, but they're going to have to find it first. Clyde Tombaugh is no longer with us. The International Astronomical Union, IAU, redefined Pluto as a dwarf planet because it had to meet these three conditions, and it didn't. I leave Pluto with a beautiful image of Pluto's atmosphere. It has a very thin atmosphere from the New Horizons probe that went by more than a decade ago. The ice on Pluto, the water ice, is so hard, has the consistency of granite rock. There are plates in hexagonal forms that form in the ice. Pluto is a fascinating world. Maybe we'll visit it again someday. It's the first of many. It's the brightest of the dwarf planets with a reflecting property about 0.5. Half of the light that hits Pluto gets reflected back. Other objects are not as bright. Some are almost as big, like Eris, not quite as big as Pluto. We found many dwarf planets out there. Ceres is a dwarf planet. It was the first discovered asteroid on New Year's Day at the beginning of the 20th century. It is big enough to cover the state of Texas just about, and it has water. Look at these bright spots. Ice. That was an unexpected surprise. It also has magnesium sulfate hexahydrate. Say that quickly. Magnesium sulfate hexahydrate. No? No one bold enough. That's an organic compound. The asteroids are more complex than we thought. We've actually sent space probes that have landed on asteroids and brought samples back to Earth. None of this happened when I was a kid. We didn't know any of this. The gas giant planets have now been renamed. Recently it was discovered that Saturn, Uranus, Neptune, all taken from the James Webb Space Telescope in infrared light, not light that we see. We've already talked about Jupiter. They are gas giants no more, mostly made of liquid metallic hydrogen and a fuzzy core of even more compressed hydrogen gas. Incredible. That's a recent development. what do amateur astronomers who are photographers, we call them astrophotographers, what can they do with Saturn? Well, raw images in small telescopes like a 10-inch Newtonian, 10-inch mirror, kind of fuzzy, but with stacking and derotation, look at that, look at the improvement. You can see a big gap right there, the Cassini division in the rings of Saturn, discovered by Cassini. There are other gaps, thousands of them. Encke discovered the Encke gap. There's a Keeler gap. This was made with 84,000 images shoved together with a $500 astro camera. Right, so you can get very fancy with this hobby. There are many gaps in the rings of Saturn. The biggest one, the Cassini, has some debris in it. Originally, astronomers wanted to send the Pioneer spacecraft through the Cassini gap. Bad idea. Encke gap, Keeler gap, very close to the edge of Saturn. We can ask space artists to show us what would it look like to see these waves caused by the moon Daphne, which orbits inside the gap. Many of Saturn's moons orbit inside the rings. There are, at last count, 274 rings of Saturn. Just a few weeks ago, it was 160. It's incredible. There's an actual photograph made by the Cassini spacecraft on its way past Saturn, its way around Saturn in 2017, making waves in the rings. And that's what it would look like according to space artist Kevin Gill. And if you want to see Saturn, the best time this year is in November. November 28th, all right, if you want to be specific, all of you write this down. November 28th, 8 o'clock, 1 minute after 8 and 37 seconds. Got it? There's a young man writing it all down. The rest of you should be ashamed of yourselves. Actually, any amateur astronomers in the audience, Saturn will be at its highest point on meridian, due south, highest point in the sky for the year on November 28th. And that's what it looks like at 8:01 and 37 seconds, Captain. And some of the bright moons of Saturn, you can see at any one time 4 to 5 of the brightest of Saturn's moons. Uranus has rings. Jupiter has rings, not only Saturn. Neptune has rings. We've discovered rings within the course of my becoming an adult, only in recent history. All this history I'm talking about, 100 years, is nothing in astronomy. Astronomers who study Mars are called areologists. They think that 1 million years is recent. Recent history. Water flowed on Mars. It's flowing on Mars now. We can actually see sand slides on Mars within the last 1 million years. That's recent. The rings of Uranus here in the James Webb Space Telescope, incredibly, these were discovered by accident, right, when the rings passed in front of a star in 1977. But William Herschel, 200 years before that, thought that he saw rings. This is considered doubtful, even though Herschel recorded this epsilon ring's color and its angle and its size correctly. How did he do that? Luck? Nobody knows. It's a mystery. Speaking of which, I've written the book, Space History Mysteries, currently unpublished. I'll let you all know when it's out. Uranus, photographed by the Hubble Space Telescope. Beautiful imagery. You can see features in the atmosphere. And even by an amateur astronomer, Damien Peach, shows what people recorded in a book I read about planets in the 1960s. All people recorded were occasional clouds. That's all we had. Visual telescopes and spectroscopes that break up the light. Al Witzel will talk about spectroscopes in a future talk for the MNAS, so don't miss that. And that's what we can see in a small telescope, relatively small. Voyager 2, the spacecraft, passed by the planet Neptune in 1989, and we now know that the color that it showed in images for decades is wrong. It's not blue. Anton Petrov has a great series on YouTube. Go check him out. He's an astrophysicist. He gets a large part of his living from YouTube videos. So if you're feeling generous and compassionate, go sign up. He has shown that the true color of Neptune is very much like that of Uranus. Right? Big revelation to me. I didn't know this until this year, 2026. For 20 or 30 years, I thought Neptune was blue. Nope. There it is. It does look blue if you don't filter it correctly. There it is in an amateur telescope picture. Triton is its big giant moon. And that's what I'm going to talk about next, the natural satellites of the solar system. In my father's time, they knew of 26 moons. I thought it was an amazing coincidence that the number for Jupiter and Saturn was the same, 9. How about that? 26 moons. As a 13-year-old, I memorized 24 of the known 33 moons in 1966. I was very proud of myself. I used to walk up and down the room where I had all my toys and games, memorizing moons. Most of you, normal people, were out there playing baseball, going to concerts, not me. So I've chosen for today, because we're running out of time, 5 of the 419 moons. 3 possibly with life: Titan, a moon of Saturn; Enceladus, another of Saturn; Europa, a moon of Jupiter; Miranda, a moon of Uranus, would be great for tourists; and Triton is a bizarre moon of Neptune, the size of the planet Pluto almost. 5 moons. Enceladus was the first to be recognized to have a giant ocean underneath its thin crust of ice. This is exciting. It has heat for billions of years. It has water for billions of years. It has organic compounds, the kind we see in the clouds of Jupiter that turn it red or brown. Billions of years, and heat. Good ingredients for life, not only primitive life like bacteria that might be blown out of Europa by its geysers, but maybe advanced life. Is there life inside one of the moons of Saturn like Europa? This one is called Enceladus. And I think it's easy to remember if you think of enchiladas. Anybody hungry? Enchiladas, Enceladus. That's an actual photograph of the geysers, the cryo-geysers coming out of Enceladus. What's a cryo-geyser? What does that mean? Cold, cryo. Titan is extremely cold, but it has methane and ammonia gases in 3 forms at once, just as there is something on Earth that can exist in 3 forms at once. Vapor, liquid, solid. What? Water, right? Does this on Titan. This is an artist's rendition of a spacecraft, the Huygens spacecraft that landed on Titan in 2005. This is a frame from an actual movie. Check it out. Go on YouTube and look up what Huygens saw. What Huygens saw. Amazing. Is there life there? Pools of organic compounds on the surface. Frozen methane. A methane atmosphere in 3 forms at once, but very cold. Could there be cryo life here? Someone recently worked out just this year that on the surface of these lakes, which we know are there, we can see them in radar, vesicles could form that trap complex compounds like RNA, the precursors to life. We know that RNA led to DNA on the Earth. Could it have happened again on Titan? We don't know. We're going to be sending a probe to land on Titan and a dragonfly flyer, just like the probe and the Curiosity probe on Mars. This one is Dragonfly. Europa is a moon of Jupiter, first recognized to have the ocean. And they've actually built a lander model and tested it in Alaska. That's not Europa, that's Alaska. Unfortunately, we're not sending a lander right away. The Europa Clipper mission is scheduled to arrive at Europa in April of 2030. It's just a flyby, though. We need something to land and drill, because there may be advanced life forms like the ones we have at the bottom of our ocean between the oceanic plates. Blind tube worms and shrimp and crabs grow there. The water is freezing cold. The temperature coming out of the smokers, 800 degrees, and they actually live there. Is that what we'll find in Europa? We don't know. We may find proof of life in our lifetimes. Some of you young people in the audience may be able to contribute to finding life on other worlds. Someday, when we have spacecraft that can travel at a continuous acceleration, 1g, so we can get to the outer planets in days or weeks instead of years. You want to go to Miranda, right down here on the lower right, the cliffs of Miranda, passed by the Voyager probe in 1986. It has Verona Rupi's tallest cliff in the solar system, thought at one point to be 12 miles high. The artist here drew 40 Empire State Buildings to show you how tall that is. 12 miles. Well, it's more like 3 to 9 miles. And there's an actual photograph of Verona Rupi's. I think this would be great for tourists. Anybody ever try base jumping? Do you know what base jumping is? Yeah, well, you could do that on cliffs hundreds of feet high and land safely because the gravity on Miranda is 800ths of a Earth gravity, 800ths, which means if you can jump, I can jump 3 feet. I'm not going to do it because I'm wired. 3 feet, if I can jump 3 feet on Earth, I could jump 380 feet on Miranda, and I can land safely with the power of my leg muscles over 400 feet. Base jumping, here's an astronaut right there. There's a wonderful movie at filmsupply.com. Check it out, of astronauts base jumping on Miranda. Triton is almost as big as the planet Pluto. We think it's a captured moon of Neptune in a backwards orbit, retrograde orbit, going the wrong way, counterclockwise. Most things, I'm sorry, clockwise. Most things in the solar system seen from the Earth's North Pole either rotate or revolve around the sun counterclockwise. Not so with Triton. Triton has cantaloupe terrain. See that cantaloupe color up there? Cantaloupe terrain. But more bizarre, it has cryogeysers and it has an atmosphere. And the geysers get pushed when they go up high enough to a certain level, they get pushed by winds in the atmosphere. We've actually seen this happen. This is a fanciful view from the surface made by space artist David Hardy, who lives in England. He is the oldest living space artist. He turns 90 this year. He's still alive. And I was lucky enough to meet him in 2005 at a science fiction convention. We've become friendly, and I've gotten to know one of my heroes from childhood. It's really a thrill for me to meet a living space artist. There are 200 of us in the world. We belong to the International Association of Astronomical Artists, a pin of which I am wearing. As of February 26th this year, there were 6,000 discovered exoplanets. I'm going to end my talk today with planets beyond the sun orbiting other suns, other stars. Our sun is a star. There are stars like the sun. There are many stars not like the sun. And recently, within the past 20 years, we've discovered that there are so many stars fainter than the sun that the number in our Milky Way galaxy has gone up tenfold, from 100 billion when I was a kid, now to 1,000 billion, which also goes by the word a trillion. Thank you. There's no need for the rest of you to be shy. Just call out the answer. So exoplanets, to over 1,000 have more than one planet. This artist, Martin Varjuk, Slovakian, showed 1,100 of them back in 2024, color-coded in size to show what some of them might be made of. The cold, small blue ones might have lakes like the ones on Titan. The big, giant blue ones might have rain of rubies and sapphires from the pressure. The hot ones, a lot of the small hot ones might be permanently facing one face to their star because they're so close to their tiny red stars. This is an actual image of an exoplanet orbiting the star Beta Pictoris, second brightest star in Pictor, a constellation that we cannot see here. That's not one of my special effects. We don't see the entire orbit because there's a dark mask blocking the light of the star. But you can see that the planet disturbs the disk of dust around the star. Incredible. We've never seen things like this until recently. only within the lifetimes of the younger people in this audience. With micro lensing, we can see things very far away. Galaxies act like a lens for the things behind them. They bend light with what? Gravity. Einstein predicted this at the turn of the early part of the 20th century. By looking at objects behind galaxies, we can actually see stars and planets and other galaxies magnified enormously. That's how we discovered this unpronounceable named giant blue planet, which probably has rings. This is an artist's impression, not a real picture. Can you remember this easy to remember name? Ogle 2012 Bulg 0950 Ulb. I remember it. It's got my initials, LB. There are all kinds of exoplanets, big things the size of Jupiter that are hot, not quite a star. They didn't quite make it, like our planet Jupiter. Did you know Jupiter gives off more radiation than it gets from the sun? There's cold gas giants like Jupiter. There's ocean worlds. There's lava worlds, rocky planets. Incredible discoveries we found. And one of the surprises that I found in researching this program today for you is that the Earth-sized planets just like Earth may be rare. So far, of the ones we've discovered, a lot of them are a little bit bigger than Earth. As an example, Kepler 452b. There's another discovered by the Kepler robot. I'm trying to move this out of the way. Whoops. There you go. In 2017, whoops. All right, I'm going to have to do it this way. In 2015, we knew of about 12 close to Earth in size. We knew that the ones orbiting the smaller stars, the cooler stars like K and M, we are a G star. These stars have less radiation, but they have planets orbiting closer. So they could be within the habitable zone where life could exist. For our sun, that's between Venus and Mars. Mars too cold. Venus, with its carbon dioxide atmosphere, has captured too much heat. Earth in the middle, just right. We now know that M stars have dangerous flares that could sterilize their worlds with radiation. But not all of the K stars are like that. And there are 1 trillion stars in our Milky Way galaxy, many, many billions of K stars. By 2018, we knew of even more habitable worlds, and the number just keeps going up and up. Earth-like worlds.
So it seems like there's a propensity for planets around your star.
Right. The hotter the star, the less likely you'll find life there. Partly because let's go to F stars. It's OBAFGK. Oh, be a fine girl, kiss me. Oh, be a fine girl, kiss me is the spectral arrangement of stars. G stars, average temperature. F stars a little hotter. They live a little shorter than G stars. Some of them about 4 billion years. Now, it took life about 4.5 billion years to arise on Earth. If you believe in evolution, many people don't. But now we can see planets forming. We can see that it does take billions of years. So will there be enough time for life to evolve and escape from an Earth-like planet around the next star? We don't know, maybe. K stars live much longer than the sun. K and M stars up to trillions of years. So they can have life around them for a long time. There may be life around stars in our galaxy that have been there millions to billions of years longer than we have. How far advanced are they? Advanced enough to know to stay away from us. The TRAPPIST-1 system is one of the most fascinating. You can see if it's scaled down to our solar system, it lies well within the orbit of Mercury, tiny. Blow it up, and the planets are all close to the star. They are not to scale in this picture, right? We've blown them up so we can see them. And these are not real pictures. These are made by an artist. We do know that planets D, E, F, and G, I'm sorry, more like E, F, and G, are in the habitable zone and could support water If it weren't for the fact there's a lot of UV radiation coming off there and maybe flares, the UV flux is a problem because recently Anton Petrov in one of his YouTube videos has shown that the kind of radiation coming from a little star like this may not support photosynthesis, the process where plants convert sunlight to energy and give off oxygen, which is vital for animal life. So are we sure yet about life on TRAPPIST-1e? I'm going to make a model of TRAPPIST-1e and put it on my website within the next few weeks. We're not sure. We're not sure. We need more studies. We're going to be able to directly image exoplanets with the Vera Rubin telescope shortly. So there's a lot to think about. There's been so much happening within my lifetime and that of my father that I expect the next 100 years might be even more mind-boggling. Some of the younger people in this audience are going to live through perhaps the first discoveries of life beyond Earth that evolved independently. Or maybe do some asteroid mining. Maybe we'll go to mine an asteroid and bring back valuable materials to Earth. Stuff we're running out of. I want to leave you with that thought. Go explore, go look forward to the next 100 years. You can find me here. You can play with 3D models, 25 of them, of worlds and objects with your fingers or any convenient pointing device. And with that, I want to say thank you. You've been a great audience. Thanks very much. We're taking questions. Any questions at all, even if it's not about astronomy, I'll tell you my favorite color, anything you want.
Play violin?
I don't play violin. My father taught me clarinet and saxophone, which I did for 30 years, got away from, and I hope to get back to. He was a very gifted musician. He had perfect pitch. He could tell you the key of any music you played or whistled or hummed or sang. I don't have that, but I have good relative pitch. Question over this way.
I'm wondering if the concept of a planet is a little obsolete. I mean, it's clearly like an 18th or 17th century thing. They got telescopes, they see these things going around the sun. They're round, they're not stars. But, you know, when a planet ceases to go around a sun, is it still a planet? An asteroid is not a planet. A comet is not a planet. We sort of presume we live on this thing called a planet. If we lived on Jupiter, we might not call it a planet, Earth, right? So, you know, there's such a variety of things going around stars, and between stars, there are now planets around multiple stars, right? That you start to ask yourself, are we constraining our thoughts by having this 16th century designation of planet or not planet?
That's an excellent question. It calls into question the decision by the IAU to redefine what Pluto is. A friend of mine is a space artist, Ron Miller, and he proposes that we call everything a planet, a cometary planet, an asteroidal planet. There are planets we've discovered that have no stars at all between the stars. So that's an excellent point. Maybe our ancestors, our descendants, maybe the younger members of the audience will redefine what those are as we discover new kinds of objects. We may need new kinds of mathematics to understand the bridge between quantum mechanics and relativity. It's been pointed out, maybe we need a whole new branch of math. So I could see how planets might be redefined. That's a good point. I haven't heard people bring that up. Thank you. So the rest of you are now experts on the history of planets, right? No questions?
You mentioned that they're not gas giants any longer.
Well, we still call the
Thanks.
4 planets, the good question, are they gas giants? Jupiter, Saturn, Uranus, Neptune, they have various things in common, their composition, the fact they have rings, but they're really, the material that they're made of has been compressed to such a state that it's not really a gas anymore. So it's a little bit of a misnomer. What we see is their gaseous atmosphere when we look through a telescope. So that's where they got their name.
and it's a liquid hydrogen.
Liquid metal. If you go, well, if anybody of you saw the Terminator movies, liquid metal, like mercury, yeah. Right, and at the core, it's compressed to such a state that they thought, originally Arthur C. Clarke, a science fiction writer who came up with 2001: A Space Odyssey, made into a movie by Stanley Kubrick. He thought that at the center of Jupiter was an Earth-sized globe that was pure diamond, compressed carbon, because we know there's carbon compounds in Jupiter. But what's there? Not sure.
I taught middle school science for many years, and it was always gas giants. I wish I could go back and correct all that.
I still call them that because that's what I grew up with.
Yeah.
But a lot of you will grow up, the younger people grow up with different terminology. Very good.
I don't think I need it.
Okay, it's for the Zoom, it's for the Zoom.
Oh, for the Zoom.
Yeah.
Sorry. Hello, Zoom. Can you recommend a book that summarizes in a fundamental way the information about planets? Just something basic, and because this seems sometimes overwhelming.
Yeah, it
So
is.
much.
I threw so much
It
information
was
out there.
great. It was
A
really.
lot of it in print. I had all my links, but I didn't see anybody taking notes or taking pictures. So it's a little bit too much. There are a lot
I
of
know
books
your
out there.
website, so is there something on your website?
Yeah,
Okay.
I could put up some reference books, but the problem with books is that as soon as
They
they're
become
printed,
out of-
they're out of date instantly because the updates are coming at us daily.
Yeah,
If you go on, look at Anton Petrov, you'll see views from 5 months ago, 2 years ago, 3 years ago. A lot of that stuff is out of date already. It's amazing. I'll try to do that. There are some good books at skyandtelescope.com. They recommend books.
okay.
Astronomy.com, space.com. That's easy to remember,
Yeah,
right?
I remember
Space.com
of that. I
does
guess
have
I guess
references.
Giant Telescope.
Yeah,
Thank
but
you.
I
And
myself,
that's-
I just read a book called The Elephant in the Universe about dark matter. It has a beautiful history about dark matter, but it was written during COVID, 2019, up to 2022. It's already out of date.
Yeah, well, James Webb is going to straighten us out on that
Yep,
too.
yep.
This is kind of off topic, but somewhat current. So NASA and SpaceX have decided not to go to Mars. It's too far away. It's too dangerous,
Too expensive.
too expensive, 20 years. But the in situ resources that were available, carbon, nitrogen, the rare earths were so abundant. And as you said, on some parts of Mars, it's even hot at the equator.
Mhm.
Instead, they're going to the moon, where there's really a dearth, just not a lot of resources. How are they going to create a permanent outpost with no carbon, no nitrogen, no rare earths, and horrible regolith that'll destroy everything, and ice that is not abundant as it is, as you said, on Mars, where it's like frozen mud?
A lot of what you said is true for both Mars and Moon. They're hostile environments that would take a lot of processing, but we made a lot of progress in the last 20 years or so. 3D printing, for instance, we can send robots to the Moon or Mars and print the facilities we need ahead of time. So a lot of that drudgery is taken away from the astronauts. The problem, as you mentioned, is resources.
The last question is, so there's been a lot of talk about helium-3 that's found on the moon, and now I understand it's not as abundant as we thought. What's the future of helium-3 on Mars? On moon,
The focus,
on the moon.
the focus of the moon is going to be a competition between nations for the South Pole for its access to water, because water can be split by hydrolysis for breathing and for fuel. And then they can do some mining and see what they can extract from the regolith. It may be sparser than we think. We're not entirely sure about that. Mars certainly has far richer resources, but the soil on Mars has been sterilized through UV radiation, ultraviolet, over millennia. And so it require a lot of processing to be able to grow stuff there. It's not like you saw in the movie The Martian. It's going to be very difficult. But these are challenges that have been addressed by the National Space Society. There is Dale Scran has written a response to the book A City on Mars, which is very pessimistic. A City on Mars, the authors go through legalities, exploration, chemistry, everything, and try to explain to us how discouraging it is. But Dale Scran has an answer for all of that. So I'd recommend going to NSS, National Space Society, and seeing what they have to say, because they answer much better than I could. Yeah, thank you. Really great questions, everybody. Everybody else looks a little dazed. Did I give you too much? Too much, right? 100 years. There's more than that. I just gave you the tip of the iceberg. When I come back for another future talk, we'll do something different. I'll slow it down. Sure, another question.
You said conditions on Mars are very different than they were depicted in the movie The Martian. How so?
The Martian didn't point out that there are perchlorates in the surface soil of Mars. It's been sterilized by ultraviolet radiation because there's no protective layer. What else? You would have to dig down.
Didn't they show it, display it as sterile?
It is, yeah. I think they had to fudge that a little bit or explain it a way that he did process the soil somehow.
Yeah.
Also, you'd have to dig more than 1 meter deep to get at the ice toward the equator where Schiaparelli crater is. Might have been better to land closer to the North Pole. But aside from that, it was fairly accurate. They did great work with the landscapes. I think it was Arizona. It kind of looked like Mars. Yeah, it was well done. Well, thank you. Thanks again. Come on back for another talk.